Okay, on the bench here today we have a 128. Now this particular unit was contributed by Michael Myers in the Commodore International Historical Society Facebook group. So thank you to Mike and everyone else involved in that particular group. Go over and check out their Facebook page. I'll put a link in the description down below. Very interesting site for anybody interested in Commodore computers and the history of the company. When I got this, I was told that it didn't work, that the power light comes on, but that's it. So we're going to hook this up and we're going to see what it does. Now, in the past, I've been hooking them up to my 1702 here, but that doesn't show up very well on the camera that I'm using. So I'm going to spin around here and hook it up where my working 128 is generally hooked up. And we'll look at it on the flat screen, and that way we can get a much better picture of the screen. You can see a little bit better what's going on. And then we'll bring it back over here to the bench to diagnose it and start troubleshooting it. Okay, the disk drive is on, the monitor is on, everything is hooked up. Now this is the setup that I use with my working 128, so I know that everything else in the system in the setup works. So let's see what happens when we turn it on. Well, we get a reaction from the floppy drive. Power light is on. Let's see what happens if I try to get a directory. Now that didn't work. Nope, nothing there either. So more than just a video issue, it would seem. Okay, let's try something else. Let's try booting up in 64 mode. Again, the drive is spinning and no response. And no response to a disk command either. Okay. One other thing, let's try. See what happens in 80 column mode. I don't expect anything to happen in 80 column mode, but let's see. Nope. Okay. So some signs of life, and yet non-operational. Okay, let's get this thing over to the workbench and see if we can figure this out. Alright, so I have to say I was hoping we would get a reaction with the drive access. That would tell me, okay, that it's just a video problem. But the fact that we didn't get anything there either suggests another problem. But it did cause the drive to spin up. And we do have a power light. So turns out our friend here is only mostly dead. Alright, so let's take this thing apart, start troubleshooting. Okay, now one thing as I flip this over, notice the difference in color between the top and the bottom. Alright, let's take these screws out. You have to be careful because the LED connector is over here on the side. You need to kind of reach in and pull that up. Take off the keyboard connector, and we can just lay this over. Take out this last screw. and we can sit the top onto the side. Nothing immediately obvious. Okay. These things are so hard to get off of here. Oh, that's interesting. Sticker here that says 8563 R9 screened. I had another one of those a while back that said the same thing. You see this here? It's 8563 R9 screened. I'm not sure if we ever exactly what that meant. So I think the best guess that we got on the Facebook group was that it went through a quality control check and was screened. I'm not sure that I like that explanation. So if anybody has a better one, please feel free to put it in the comments below. Okay, so let's take a look around in here and see what we've got. Let's just start here with this interesting one. This is the 8563. You can see this is revision 9. The 8563 controls the 80 column output. This is the 8564. This is the VIC2E chip that controls the 40 column output. We've got our trusty old SID here, 6581. Over here we have the 8722. This is the MMU, the Memory Management Unit. Down here we have a 6526 CIA. We've got another one over here. We've got the Z80 here. This is going to be an interesting one for us because when the 128 boots up, it boots the Z80 first. So any problems on boot up, the Z80 is always a place to keep an eye on. Here's the 8502. This is our main processor. Over here we have the 8721. This is the PLA, the Programmable Logic Array chip. This here is just some static, is 16K of static RAM. This one is the character ROM. Over here we have some more ROM chips. This one is interesting. This is for the 64 basic and kernel combined on that ROM. This is basic low and basic high for the 128, and this is the 128's kernel ROM. One of the great things about the 128 is that so many of the chips are socketed. The CIAs are socketed, the ROMs are all socketed, at least these four are. Both of the video chips here are in sockets. The SID is in a socket. So the first thing that I'm going to try is I'm going to lift each of those up out of the sockets a little bit, push them back down in, and see if that makes any difference, if maybe this is just a question of we're not getting good contact somewhere. Okay, so all the chips that we lifted socketed have. So I'm going to plug this thing into the 1702 that I have here handy, and we'll see if there's any difference at all. All right, let's see what happens. Nothing. Okay, so we did not get lucky and just have an instance of a chip not properly seated. Okay, so I've removed the board from the case and now it's time to start testing it. And I'm going to start quite literally by the book. This is the C128 Diagnostic Instruction and Troubleshooting Manual from Commodore. And section 2 is all about the checks for when you have no video on power up. Now, step 1 says to test for 5 volts on pin 25 of the SID. All right. So we've got the computer is turned on. SID is here. With these, you start at pin 1, count up to 14, and then back down to 28. So if I touch pin 25, I should be getting 5 volts. I'm getting 4.65. Alright, so that's a bit low even under load. You expect it to be a little lower than 5 under load, but that's a lot lower than 5. Step 2 says to test pin 28 on the SID, and we're looking for 12 volts. So we have 12 volts. Yes, we do, 12.01. So the 12 volt line is good. Now, in the manual, it says if any result is incorrect, check the power supply. So I know this is a good power supply, and we can demonstrate that. If I turn it off, I can come in here and I can touch my 5 volt pin, and you can see I'm getting 5.05 volts coming in from the power supply. Now, the first step is in checking for a defective 5 volt supply is to measure the voltage on the positive leg of capacitor C107. C107 is right here. So if I can get under here and touch that positive leg with the computer on, .66. Not really any different than what I was reading on the SID. Okay. So if that's an incorrect result, then I'm supposed to go to step 2, which is to measure the voltage on the positive leg of capacitor C99. C99 is right here, and I'm getting 4.68. Well, I'm still going to call that incorrect. And then it says to measure the voltage on pin 1 of connector CN11. Right, that's this filter right here. Now, the thing is, if it's this filter, then there should be a different result coming into the filter than there is going out of the filter. Right. But if I test that right now by touching my 5 volt pin coming in from the power supply that was reading 5.05 a minute ago, and it's reading 4.7 now, and I touch over here and I'm still getting 4.66, then there's not really any difference in voltage going across that line filter. So that's not going to be the issue. Alright, it seems likely to me that the problem is probably one of the chips drawing too much current on that 5 volt line. Because we know we have good power coming in, we know we've got the same on both sides of the line filter, we know we've got the same before and after the switch. So we're getting good power coming onto the board, it's just being drained somewhere. Alright, so the next problem to test is the system reset. In section 2.3, it says the first thing to do is to test the signal on pin 8 of U63. That's up here in the corner one of those infamous 7406s that fail all the time. And it should go from 0 to 5 volts in about 1 second when it's turned on. So let me get to pin 8. Okay, and we'll turn it on. Okay, pretty good. Turn it off, and we're back to 0. So that's good. So the next thing is we're going to check pin 9. We're going to start at 5. It should start at 5, and then it should drop to 0 when it's turned on. So let's turn it on. High and then drops. Okay, good. Next step is back to pin 8. It says we should see a slow rise from 0 to 5. So we're going to start with it off. Okay, turn it on. Slow rise. Okay. Turn it off. And now on pin 12, we should see a slow rise from 0 to 5 and then a quick drop to 0. So let's turn it on. And as far as we get is 0.1. So that's a failure. So it seems that this 7406 might be bad. So I'm going to replace that one, and then we'll see what happens.
Okay.
Done. Thank you. Okay. So, update. Following the advice in the troubleshooting guide, I replaced the 7406 chip over here in U63. I put a socket in, put a new chip in, no change. The other two things that could be causing a problem with the reset circuit are the capacitor in C92 and the diode in CR16. So I replaced the capacitor. I'm going to recap the whole board eventually anyway. And I took out the diode and tested it, and the diode tests fine. So I just reinstalled the diode. You can't really test a diode when it's installed in the board, so that's why I had to remove it. So I removed that, tested it, everything's fine. So with the new chip, a new cap, and a known good diode, there's still no change. So we have to move on to some other possibilities. Now, according to the troubleshooting guide, the next thing to test are the system clocks. Now, I can't test those because I don't have an oscilloscope. So I'm just going to have to skip that step, and if I try everything else and nothing else works, then maybe I'll see if I can borrow an oscilloscope from somebody. I know I should probably get one of those at some point, but I don't have the money for one right now. So we're just going to have to test the other things first. Okay, so the signals to the VIC go through the PLA first, so we need to see if that's our problem first. Now, according to the troubleshooting guide, we should be looking on pin 9 for 4 to 5 volts. So let's find pin 9. And we're reading 1.61. Clearly that's not right. Alright, the next step is to look at pin 13, and we should go from 0 to 5 on reset. Okay, so let's do a reset. Turn off, turning on. Well, that's not right. Given that result then, the troubleshooting guide says that it could be a defective PLA in U11, or it could be the logic chips in U8, U37, or U61. It also says, though, that the input that we were looking at on pin 13 is dependent on the Z80. So we might be back to the Z80 here. Okay, so I'm going to test the Z80 next instead of the logic chips because we're not just looking at a video problem. Remember when I first was testing it and I tried to do a directory and that wouldn't even work? So I don't think we're looking at just a video problem here. So I'm back to the Z80 instead of just those logic chips. So let's take a look at the Z80 here. Now, some of this stuff I can't test because, again, I don't have an oscilloscope. So I can test on pin 6, I should be getting 5 to 6 volts. I'm getting 0.8. That's not good. Alright. I can test on pins 20, 22, I should both be getting 4 and 5 volts, 4 to 5 volts. That's not bad. Okay, that's in the range it says I should be looking for. And so let's look at pin 23. That's the one that traces over to where I was getting that bad reading on the PLA. So on pin 23, I should be getting 4.5 volts to 0 on a reset. So let's turn it off. Looking for 4.5 to 5 volts on a reset. Not even close. Alright, so we're seeing a lot of issues here with the Z80. I'm beginning to think that's where my problem is, since we're not even getting a boot up. So, I think what I'm going to do is I'm going to swap out the Z80 with one that I know works, and we'll see if that works. Okay, well, it seemed to me that all the signs were pointing toward a bad Z80. So I removed the one that was in there, added a socket, put in a Z80 that I know works because it came out of another working machine, and still no joy. I put the Z80 from this machine in my working one and booted that up, and it booted up just fine. So clearly the Z80 wasn't the problem. I will point out one thing I had to do here. This one, the pin, one of the pins on the Z80, I think that's pin 33, had broken off of this one. So I used the leg from a capacitor that I had changed a while back and just pushed that into the spot on the socket, and then soldered it to the leg of the chip. So I'm actually going to cut that off now, but I wanted to leave it on so that I could mention that. Let me talk for just a second about how I'm actually working on all these things. I don't generally get an hour, 2 hours or more at a time to sit down with these things and work on them. I get 15 minutes here, 20 minutes there, maybe half an hour if I'm lucky, and then I have to go do something else. So sometimes I forget things, and sometimes I lose track of where I was in a process. If you remember, when I first tested this, and you can go back in the video and check, not only did I check 128 mode, 64 mode, and the 80 column mode, but I also wanted to see if it was just a video problem or if it was something more widespread. So I tried loading a disk directory and nothing happened. Right? So what that told me at the time was it was more than just a video problem. But as I started working on it, which was actually a couple days after that, I'd forgotten all about trying the disk access. So a lot of what I was working on originally here was focused on the video display. What I probably should have done is not worried about the video display at all and tried to figure out why I wasn't getting any response at all from the machine, including disk access. Well, regardless of that, the troubleshooting steps that I took still came back pointing to the Z80. Right? And if the Z80 is not working, nothing else is going to boot up. Well, I replaced the Z80 and we're still not booting up. So, there are some other logic chips here that I can test that work with the Z80, and one of those might be our problem. One other thing that I want to mention before I move on, when I swapped the Z80 out of my other working machine, I had the board open. I thought, I'm going to test the voltages and just see what I get on that machine too. Because I thought as I was testing the SID and I was testing voltages on the various chips and at the power connector here, what I was getting was readings in the 4.6, 4.7 range on the 5-volt line. And to me that seems awfully low even under load. Okay. But when I checked my working unit, I was getting readings that were basically the same. Everything was in that 4.6, 4.7, 4, maybe up to 4.8. But everything was still in that range. So I'm thinking that what I was seeing as a low voltage might not actually have been too low after all. So I feel like I might have gone off on a bit of a wild goose chase there. Okay, so let's see if we can focus on the logic chips and see if we can figure out what might be the problem there. I want to check the 8502 operation as well. Let's take a quick look at the pinout. This is from the Commodore's service manual for the 128. Let me see if I can zoom in a little here. So we can see here on from pins 31 to 38, these are our data lines. Let's start with the letter D. And then over here on this side we have the address lines, starting with A, running from pin 7 to 20, and then 22 and 23. So we're going to start by checking to see if there's activity on these lines. Now many of you have seen one of these before. This is a logic probe. You just connect these to the power on the board. Make sure you're set at TTL and on pulse. You'll see here we've got a light that lights up for high and one that lights up for low. Okay, so this will tell us if there's activity on any given line. Unlike an oscilloscope, it's not going to tell us exactly what that activity looks like, but it will tell us if there's activity. So I'm going to clamp over here on the cassette port for power and ground right there next to it. Now we're going to start just testing for activity on 7 through 20. Now with the orientation of the 8502, this is pin 1. We count this way, over and up. So starting at pin 7, we're going to be at 1, 2, 3, 4, 5, 6. I'm going to do it this way. Okay, so I've got activity. doesn't really matter at this point what the activity is. We're just mostly looking to see if we have activity. Yeah. So it would seem that the 8502 is alive. Now we can check one other thing here. We can check the reset circuit, which we've already done with the IC over here, the logic chip in U63, and then we checked, remember, the capacitor here in C92 and the diode next to it. But if we check on pin 40 of the 8502, it should be, we should get a low reading here when the computer's first turned on, and then it should immediately go to high. And then if we press the reset button, it should also be low. Okay, so let me get this in here where you can see it. Turn the computer on. Starts low, immediately goes to high. Hit the reset. Low, immediately goes to high. Alright, so our reset circuit seems to be working just fine. And the 8502, as far as I can tell, seems to be working fine. So we're back to checking those logic chips. Alright, looking at the logic chips now. We have 3 so far that we need to focus on, which is U61, U8, and U37. 61 and 8 are both 74LS08, and the U37 is a 7406. So let me start with the 7406 and U37. Now I'm looking at the pin assignments and the logic diagrams here, and what this tells me is basically as I go through the pairs of pins, if it's high, if the first one's high, the next one should be low. If it's low, then the next one should be high. And that should be the case running through pins 1 to 6 and then 8 through 13. Okay. So that's what we're looking for. So we're going to start here. Pin 1 is low. Pin 2 is high. That's good. Low, then high, low, then high. High, then low, low, then high, low, then high. Alright, so the 7406 there seems to be working correctly. So let's try in U8. This is the 74LS08. This one's a little more complicated. Okay, so here's the logic diagram for this one. We've got 2 inputs and an output. Okay, so if the input on A is, let's say, low, and the input on B is, let's say, low, then the output here, which is Y, should also be low. If, let's say, the input is high and the second input is low, then the output should be low. So let's go through and let's test this one and see what we get. Okay, so pin 1 tests low. Pin 2 That's high. So pin 3 should read low. And it does. Okay. Pin 4 reads high. Pin 5 reads high. So pin 6 should also read high. And it does. Right. Pin 8 reads high. Pin 9 reads high, so pin 10 should read high. Pin 11 reads low. Pin 12 reads low. According to the truth table, pin 13 should also read low. And it's reading high. That could be a problem. Up here on U61 we have the same kind of chip, another 74SO8. Let's test this one. Pin 1 is high, pin 2 is high, so pin 3 should be high. Okay. Pin 4 is high, pin 5 is low, so pin 6 should be low. And it is. Okay. Pin 8 is low, pin 9 is low, so pin 10 should be low. Pin 11 is low, pin 12 is high, so pin 13 should be low. And it is. So certainly from that, U8 is suspect. Well, after that one wonky reading on the logic chip here in U8, I swapped it out with one from a working unit, and that's not the problem. I tested this chip in the other board and it worked just fine. So clearly this logic chip, not the problem. The other logic chips tested it fine, so I don't think we've got a problem there. Alright, the next thing I decided to check was the PLA here in U11. Now in the troubleshooting manual, it says that if you measure the signal on pin 13 of the PLA, it should go from 0 to 5 volts on reset. Okay, well, pin 13, get this in here, is right here. You can see right now we're measuring 0.1. We do a reset, we turn the computer off, and then on, we just go back to that 0.1. So we should be reading 0.5. Now, if this is an incorrect result, according to the troubleshooting manual, then it indicates either a defective PLA or defective logic chips in 837 and 61, which we've already tested. So this is pointing to the PLA. So I'm going to pull the PLA from my working unit, swap them, and see if that makes any difference. Okay, so I have two boards here. This is the one I'm working on. This is the one that I know works. I have pulled the PLAs from both and installed a socket. Already switched the PLAs, so let's test the so far non-working board with a good PLA and see what happens. The PLA was not the problem. We know the problem on this board is not the PLA. We know it's not the Z80. We know it's not most of the logic chips. We know it's not the VIC. kind of wondering if it's the 8502. Okay, so we're ready to test the 8502, and the first step in testing, according to the system troubleshooting guide, is to test pins 2 and 39. We're looking for 4 to 5 volts level with negative pulses. Well, I'll check the pulses in a minute. Let's check the voltage first. Okay, so pin 2, 0.15. That is not 4 to 5 volts. What about over here on 39? 4.67. Alright, well that's okay. That's giving me a faulty reading. According to the manual here, it says that that means that either the 8502 is faulty or the logic chip in U61, and we've already tested U61. Let's see what our logic probe has to say about pin 2. Well, it's just saying low. It's not reading any pulses. And again, without a oscilloscope, not really much more that I can do in terms of troubleshooting that. I guess the next step is to pull the 8502, swap it with the one from my working system, and see if that works. Let's see if it works. Still nothing. Okay, well, so far following the diagnostic and troubleshooting manual hasn't really gotten me anywhere. So I took a look at Ray Carlson's site, and I went through his list of chips that could cause no screen or no boot up. And having already eliminated a lot of the possible chips that he lists as possible failures, we're down to 2 options. And that's these 2 logic chips right here in U14 and U15. Okay, these are both 74LS257s. And I'm wondering, because this one has the wire, the bodge wire that goes over to the Z80, which is required for startup, I'm wondering if maybe it's this logic chip that's causing the problem and not the Z80. But I don't know. So what I'm going to do is I'm going to desolder both of these, put sockets in, swap them with the ones from my working board, and see if that makes any difference. Okay, so I've swapped out this chip. This is still the original for this board, but this one comes from a working unit. So let's see what happens. Still nothing. Alright, let's swap the other one. Alright, now both of these are from my working unit. Let's see what happens. Okay. Okay, the next thing I'm going to try is to piggyback some RAM. I've seen RAM failures before. I've never seen one that actually resulted in a complete black screen, but I've been told that that happens. So I'm going to try the piggyback approach here, where you take a good RAM chip, and I know this was good, it came out of my working board, and you piggyback it on top of another one. So you just kind of line it up here, push it down, you make sure you're making good contact on all the pins, turn it on, and see if anything happens. Now, nothing happened right there. So we'll turn it off. We'll lift the chip and try it on the next one. Verify good contact, hit the power, and nothing. Alright, so I'm going to try this on each of the other chips and see if anything happens, if we get any difference whatsoever. Okay, so I've tried the piggyback approach on all 16 chips and no effect. So that leads me to believe that either all of the RAM chips are good or multiple RAM chips are bad, so that just replacing one wouldn't solve anything. Alright, one other thing I'm going to try is I'm going to swap out the ROMs here with the ones from my working board. I really don't think this is the problem, but I want to just swap them out and give it a shot just to eliminate the possibility completely. So let's swap these out. Because I don't think this is the problem, I'm just going to try all 4 of them at once. If I really thought that one of these ROMs was the problem, I'd do it one at a time. But I really don't think that's the case, so we're just going to do them all in one go. And if the thing boots up, then we'll go back and figure out which one of them is the culprit. Okay. Well, I'll be darned. Okay, that actually worked. So I don't know if you can see the screen very clearly here or not, but everything's right. It's got the right amount of bytes free, so clearly all the RAM was good. Clearly one of these ROMs is the problem. Now we just need to figure out which one. So after all that, it turns out that the problem is one of these ROM chips. I never would have suspected the ROM chips, at least not before everything else that I've tested here. Generally when I've had a ROM failure, you don't get a black screen. This is the first time I've seen that, so I've learned something new. Learned a lot new on this project. Okay, so what I'm going to do, you can see here that everything is working the way it's supposed to work. Actually, I don't know if you can read that screen or not, but trust me, it's right. Okay, so I'm going to turn it off, and I'm going to start by replacing the kernel ROM chip. Now this is the one from the original one from this board. So if this works, I know it's one of the other chips. If it doesn't work, I know it's that one. And we're dead. Well, I think we found our problem. So now we just have to acquire another kernel ROM chip. Okay, well I guess it's my turn to do an unboxing video now. After I discovered the 128's kernel ROM was the source of the problem, I mentioned it on the Facebook page, and John Saller volunteered to send me a burned copy of the ROM. So let's open this up. have here. Ah, not a burned copy, an original. All right, well, excellent. Thank you, John. So let's put this in here and fire this puppy up. All right, let's see what happens. Beautiful. Okay, so before I wrap up this part of this restoration series, I want to send my thanks again to Michael Myers and the Commodore International Historical Society Facebook group and the admin over there, Dave McMurtry, for giving me the deal on the 128. I also want to thank John Saller for the much needed kernel ROM chip that brought the computer back to life. Big thanks to you both. Couldn't have done this video without you, and it is appreciated. I also want to say thank you to everyone who's still watching. This video went much longer than usual for me, but this project was a real head scratcher. I learned a lot, especially about how not to follow repair manuals, and I hope you did too. In the next video, I'm going to clean up the case and the keyboard, do a bit of retro brighting using some new 3D printed tools that I found on Thingiverse, and solve a bit of a puzzle that I ran into when I reassembled the computer. See you next time.